We're going to go on a little journey into algebra here to find the equation of the locus of points that satisfy this specific condition. Now remember this condition where I have two distances added together equaling a constant, that's going to give us an ellipse. So this is what we're looking for. Now, the other thing that I need to keep in mind are my distance formulas, where remember my distance formula comes from Pythagoras. And it says that it's the difference between my x-coordinates squared plus the difference between my y-coordinates squared. So I'm going to employ that for this question. Let's start off by having a look at the distance from A to P. So my distance AP is going to be the distance from my point P, which we'll just call X. Take away my A coordinate. Now my A coordinate for the X's is a 1. And then my distance from P in the Y coordinate will be X or Y minus the 0. So I'm just going to call that Y squared. Now let's have a look at my B coordinate from B to my point. So BP. When we think of the same sort of process, my distance is going to be X minus the X coordinate here, which is -1 squared plus Y squared as well, because my Y coordinate is 0. So I'd have Y minus 0 all squared. And remember that that plus that will equal 3. So let's write my condition down here. This AP plus BP, which equals my square root here and my square root here. So therefore, X minus 1 squared plus Y squared plus X plus 1 squared plus Y squared, keep that under the radical there, equals 3. Now I need to use some algebra to get to my ellipse style equation so that I know what the equation of this locus is. Now to deal with all this square root business, I'm going to have to square both sides. But believe me, if I do it like this and keep these two radicals on this side, things are going to get ugly. So what I'm going to do is move one of these across to the other side. Or more correctly, I'm going to subtract 1 from both sides. So I'll have X minus 1 squared plus Y squared equals 3 minus X plus 1 squared plus Y squared. Now let's square both sides and I'll get X minus 1 all squared plus Y squared equals, remember, when I square all of this, it's my first term all squared, so that'll be 3 squared, minus 2 times my first term times my second term plus my final term squared, which will be X plus 1 squared plus Y squared. Now that I've squared both sides, let's have a look at what we've got and maybe start knocking out or collecting some terms. You'll notice I've got a Y squared here and I've got a Y squared here, so I can get rid of them. I can also start expanding my X terms to see what I'm left with. So I end up with an X squared minus 2X plus 1. On my left-hand side, I'll have 9 minus 6 root X plus 1 squared plus Y squared. And then when I expand this final term, I'll have X squared plus 2X plus 1. You'll notice I can also get rid of a couple of other terms now. I've got an X squared on the left, balancing an X squared on the right, so I can simplify those down. I've also got a plus 1 on the left and a plus 1 on the right, so I can deal with that. And what I want to do now, again, I'm going to need to deal with this square root. I'm going to try and have all of my unsquare rooted terms on one side of my equal sign and all of my square rooted terms on the other side. So let's try and get all of this x and constant business over to the left. An easy way to make sure that we haven't forgotten any terms in a complicated equation like this is to cross them out as I do them. So I have a negative 2x there and a 2x, and I don't see any more terms where the x is the leading term, so I have a negative 4x over the left-hand side. I've got the 9, so I'll put a 9 over there as well, and I'll knock that out. And I'm left only with this radical and the 6 on the other side, so let's leave that there. And finally, I notice every term is negative, so let's make it a little bit friendlier by making every term positive. So now I'm ready to square both sides again, and you'll notice that I'll get rid of this square root radical. And remember, I did tell you this was going to be a journey into algebra. Let's go for it. Squaring both sides, I get 4x plus 9 all squared equals 36 outside of x plus 1 squared plus y squared. So now let's expand our left. I get 16x squared plus, remember, 2 times my first term times my second term plus my second term squared will be 36x plus 1 squared plus 36y squared. We'll keep going with collecting and expanding and doing all that sort of algebra business. 16x squared plus 2 times 4 is 8 times 9 is 72x plus 81 equals 36. Let's expand this one. X squared plus 2x plus 1 plus 36y squared. Then we'll smooth out our expression over on the right, expanding this. And then let's see if there's anything we can clean up and have a look. We've got a 72x and a 72x. So that's handy as well. Now we've got a 16x squared and a 36x squared. So collecting my x squared terms, 16 and 36, that gives me 20x squared. I've got an 81 and a 36 here. So my balance is 45 over on this side. So let's cross those out. And I have a 36y squared over on the right. Now I have something that looks like it might end up forming our ellipse equation. And therefore it's probably a good idea to remember what our form of the ellipse equation is. Now remember, we have x minus h squared over a squared plus y minus b squared over, that should be y minus k squared over b squared equals 1. Now our h and k are the centre, and our distance from the centre left or from the centre to the right is a, and our distance from the centre up or the centre down is b. So this looks like it's capable of being moved across into this form. First of all, let's swap my x squareds and y squareds, put everything over the other side, and we'll just rotate it around the equals sign. And then what we need to do is we need to make sure my right-hand side is a 1. So therefore it'll be 20x squared over 45 plus 36y squared over 45 equals 1. And now let's make sure our bottom line or our denominators fit the idea of a number. So I'll have x squared over 45 over 20 plus y squared over 45 over 36 equals 1. And the last thing I have left to do is to make sure that I simplify these down as much as possible. So I'll have x squared over 9 over 4 plus y squared over. Let's look for common factors here. I think I can do 9s here, so I'll have 5 over 4 equals 1. And now let's consider taking the square root so I can present them in squares. So x squared over 3 halves squared plus y squared over root 5 over 2 squared equals 1. And now what I've done is I've used the distance formula to find the equation of the locus of points satisfying this ellipse. And I've spent 10 good minutes doing some pretty riveting algebra. And there's our ellipse. If you found this video helpful, please subscribe or like. Thanks.